Variables and mutability. As mentioned in Chapter 2, by default, variables are immutable. This is one of many nudges Rust gives you to write your code in a way that takes advantage of the safety and easy concurrency that Rust offers. However, you still have the option to make your variables mutable. Let's explore how and why Rust encourages you to favor immutability and why sometimes you might want to opt out. When a variable is immutable, once a value is bound to a name, you can't change that value. To illustrate this, let's generate a new project called Variables in your projects directory by using cargo new variables. Am I going to do this? No. Maybe. Probably not. Hold on. So I'm trying to learn too many things at once, I think. Hey, you know what? This seems to be working. Okay, I did it. No promises I'm going to keep doing this. So, where am I? Let's generate a new project called Variables in your projects directory by using cargo new variables, or maybe on my desktop. Then, in your new variables directory, open source main arse, then replace its code with the, okay, we'll do. So we will open main and replace code. Okay, so this goes bye-bye, and we'll say, oh gosh, oops. Let x equal 5. Print on the variable x if Ferris. Yeah. X. Close. That thing. Now, x equals 6. And that'll do. That'll do, pig. All right. Yes. Cargo. Run. Run, cargo. Save and run the program using cargo run. You should receive an error message as shown in this output. Cannot assign twice to immutable variable x. This example shows how the compiler helps you find errors in your programs. Even though compiler errors can be frustrating, they only mean your program isn't safely doing what you want it to do yet. They do not mean you're not a good programmer. Experienced Rustaceans still get compiler errors. The error message indicates that the cause of the error is that you cannot assign twice to immutable variable x, because you tried to assign a second value to the immutable x variable. It's important that we get compile time errors when we attempt to change a value that we've previously designated as immutable, because this very situation can lead to bugs. If one part of our code operates on the assumption that a value will never change, and another part of our code changes that value, it's possible that the first part of the code won't do what it was designed to do. The cause of this kind of bug can be difficult to track down after the fact, especially when the second piece of code changes the value only sometimes. In Rust, the compiler guarantees that when you state that a value won't change, it really won't change. That means that when you're reading and writing code, you don't have to keep track of how and where a value might change. Your code is thus easier to reason through. But mutability can be very useful. Variables are immutable only by default. As you did in Chapter 2, you can make them mutable by adding mut in front of the variable name. In addition to allowing this value to change, mut conveys intent to future readers of the code by indicating that other parts of the code will be changing this variable value. For example, let's change source/mainers to the following. Okie doke, will do. So they want me to say let mut. Oh, beautiful. All right. I'm not going to do all that. Yes, yes. So now, cargo run. Ta-da! When we run the program now, we get, yay. We're allowed to change the value of that x binds to from 5 to 6 when mut is used. In some cases, you will want to make a variable mutable because it makes the code more convenient to write than if it only had immutable variables. There are multiple trade-offs to consider in addition to the prevention of bugs. For example, in cases where you're using large data structures, mutating an instance in place may be faster than copying and returning newly allocated instances with smaller data structures. Creating new instances and writing in a more functional programming style may be easier to think through, so lower performance might be a worthwhile penalty for gaining that clarity. Differences between variables and constants. Well, real quick, there's also this. So I can say let x equal 5, and then I can say let x equal 6, and this works too. So there's that. Differences between variables and constants. Being unable to change the value of a variable might have reminded you of another programming concept that most other languages have: constants. Like immutable variables, constants are values that are bound to a name and are not allowed to change. But there are a few differences between constants and variables. First, you aren't allowed to use mut with constants. Constants aren't just immutable by default, they are always immutable. You declare constants using the const keyword instead of the let keyword, and the type of the value must be annotated. We're about to cover types and type annotations in the next section, data types, so don't worry about the details right now. Just know that you must always annotate the type. Constants can be declared in any scope, including the global scope, which makes them useful for values that many parts of the code need to know about. The last difference is that constants may be set only to a constant expression, not the result of a function call or any other value that could only be computed at runtime. Here's an example of a constant declaration where the constant's name is max points and its value is set to 100,000. Rust's naming convention for constants is to use all uppercase with underscores between words, and underscores can be inserted in numeric literals to improve readability. Constants are valid for the entire time a program runs within the scope they were declared in, making them a useful choice for values in your application domain that multiple parts of the program might need to know about, such as the maximum number of points any player of a game is allowed to earn, or the speed of light. Oh, hey, shadowing, that's the thing. Okay, so let's have a constant. So we're going to come in here and say, can I put a constant up here? Let's try it. I'm going to say const poo car equals I don't have a poo-poo emoji on hand. How about that? Yeah. All right. So now we'll come down here and say, wait a minute. We will say print line, we'll have one of these, that wasn't it, I have one of these, and then we'll, come on now, and then we'll come over here and say poo-poo. Okay, so P-O-O underscore P-O-O. Should work, I suppose. Yes, especially because it didn't tell me no. Right, quit. And cargo run. There's my poo-poo. Shadowing. As you saw in the guessing game tutorial in the comparing the guess to the secret number section in chapter 2, you can declare a new variable with the same name as a previous variable, and the new variable shadows the previous variable. Rustaceans say that the first variable is shadowed by the second, which means that the second variable's value is what appears when the value variable is used. We can shadow a variable by using the same variable's name and repeating the use of the let keyword as follows. Fin main let x equal 5, let x equal x plus 1, let x, ooh, okay, I can do that. So go back into emain, let x equal 5, and I guess we can do this. Let x equal x plus 1. Well, why not? How about 41? And then we will let x equal x plus, how about 1? Irony. And then I'll go down here and I'll say the width of x is just x, just like that. Okay. Writing looks good. Quitting looks good. Over here. Let's clean it up a little bit. There you go. Cargo run. Yay. This program first binds x to a value of 5. Then it shadows x by repeating let x equal, taking the original value and adding 1 to so the value of x is then 6. The third let statement also shadows x, multiplying the previous value by 2 to give x a final value of 12. Oh, I should have multiplied. I didn't see that. Oh well. When we run this program, it will output the following. Shadowing is a little different from marking a variable as mute because we'll get a compile time error if we accidentally try to reassign to this variable without using the let keyword. By using let, we can perform a few transformations on a value, but have the variable be immutable after those transformations have been completed. The other difference between mute and shadowing is that because we're effectively creating a new variable when we use the let keyword again, we can change the type of the value but reuse the same name. For example, say our program asks a user to show how many spaces they want between some text by inputting space characters, but we really want to store that input as a number. Have let spaces equal some spaces, and then let spaces equal spaces dot len, which means something. Length. There's a length. It's not a function. I'm not a programmer. What do you call this thing? Well, let's do it. Why not? Are we going to do that? Let's keep reading. This construct is allowed because the first spaces variable is a string type and the second spaces variable, which is a brand new variable that happens to have the same name as the first one, is a number type. Shadowing thus spares us from having to come up with different names, such as spaces underscore str and spaces underscore num, Instead, we can reuse the simpler spaces name. However, if we try to use mute for this, as shown here, we'll get a compile time error. Oh, that sounds like a challenge. So we can say, let's say let spaces equal 1, 2, 3, 4 of them. That's a string. Now we're going to say let, let spaces equal spaces dot length of spaces, and then one of dems. Okay, so now we're going to want to println bang. No. And then this business, right? And y'all like watching me ride the Vim struggle bus? I really got to change my colors. I could, yeah, I'm going to open this in a different terminal in just a minute. So what do I want to do here? Print line, we got that, and then we want it to be spaces. Okay, so we'll say spaces. And then we'll come back in here and say, before I forget, do that. Okay, so then, right, come back and say some words, right? So here, they are those spaces. And then what? I'm curious. A question mark. Oh, I never used poo poo. Okay. Well, we're gonna fix that right now. Oh no. Go back. Oh Lord. Why am I Oh, that's right, because I'm not in insert mode. No, that's not right. Oh, it's because of screen recorder has hijacked my control R. All right. And that's the end of this one.